Alright, so the equation here is you're mixing NaNO3, right?
Oh no, it was NaCl.
Yeah, you're mixing NaCl
and AgNO3.
and AgNO3, silver nitrate. So if you remember from the solubility table,
Yep, all nitrates are soluble.
all nitrates are soluble, and sodium chloride is also soluble. So this is nothing more than Na plus aqueous plus Cl minus aqueous, and this is nothing more than Ag plus aqueous plus NO3 minus aqueous. So without having to go into the solubility table, NaNO3 is aqueous because all nitrates are aqueous. But if you go and look at your solubility table, you'll find that silver chloride, like you did in the lab just now, is insoluble, so it will precipitate out. All right, so let me rewrite this double displacement reaction. So the molecular equation, not the net ionic equation. The molecular equation is this. And they tell us that what was it, 0.9 grams of this?
Yep, so there's 0.9 grams
You start
of
out
sodium chloride and then also
0.9
silver
grams of
nitrate.
this, and the product is 0.602.
0.602 of silver chloride.
Okay, this is the what I'm going to call the actual yield. And this is how much we get when you do the reaction. All right, we need to figure out what is the theoretical yield,
Okay.
which is if everything is perfect, you're a robot and everything is beautiful, how much can you actually get? Okay, how much you can actually get. So we need to ask ourselves two questions. Okay, this reaction will go on until either this is gone, or this reaction will go on until this is gone. One of these is going to be gone first. Once one of these is gone, the reaction is done. Can't go on anymore. Can't go on anymore until because you ran out of either this or this. Once one of these runs out, it's over. Okay? So we're going to ask ourselves two questions. Okay, the first, before anything. Okay, before I get ahead of myself, before anything, you need a balance. Okay, so you need to balance this equation. So 1 Na, 1 Na, 1 Ag, 1 Ag, 1 Cl, 1 Cl, and NO3, 1 NO3, 1 NO3. So you're balanced, which is good. Okay, step 2, you're going to ask yourselves two questions. Okay, the first question I'll call 2A. Okay, how much of this product, okay, this is a precious product, we always want to make more of product. How much AgCl product will you make okay, if all the NaCl is used up? Okay, we're trying to find the limiting reagent here. So how much AgCl will you make if all of the NaCl is used up? So start with what you're given. Okay, we're starting out with 0.90 grams of NaCl. All right, let's go ahead and convert that to moles. 1 mole of NaCl. It has how many grams of NaCl? Well, oh, you have it? I was going to use Google, which I would hate using, but if you have it.
I've got it over here on my paper.
Okay.
I'll make it a little bit easier on you, hopefully. Yeah, here it is. So NaCl.
Na is 23 and Cl is 35.
Yeah, so 58.45.
That's about right. 58.45 grams of NaCl. All right. Now you tell me, Alex, how many moles of Cl react to give you how many moles of AgCl?
It would be 1 and 1, correct?
Yeah, very good. So I'm going to put the 1 mole NaCl at the bottom to cancel things out, and 1 mole AgCl at the top. And then I'm going to convert this 1 mole AgCl to grams.
So AgCl, 1 mole of it is 143.32.
Excellent, thank you. 32 grams of AgCl. All right, on our calculator. So really quickly on our calculator, we have 0.90 times 143.2, 143.32, divided by 58.45, 2.21, I'll say 2.21 grams of AgCl are produced.
And this is assuming that it'll be the full sodium chloride that's used up.
Assuming the full, very good. Assuming full, all the NaCl is used up,
Okay.
are produced if all reactant NaCl is consumed or used up. Okay. So that's theoretically, in theory. All right. All right. Now we're going to ask ourselves a second question. Okay, we're going to ask ourselves a second question. And that question is, how much AgCl solid, because remember, we always want to make as much solid as we can, will you make, as much product as you can, will you make if all the, now we already answered it for all the NaCl, okay, if all the AgNO3 is used up. If all the AgNO3 reactant is used up. Okay. So they tell us we started off with 0.90 grams of AgNO3. Okay, 1 mole of AgNO3 has how many grams?
1 mole of AgNO3
Is that
169.87 grams.
169.87 grams of AgNO3. Okay, I got to ask you this, going back to our balanced equation, how many moles of AgNO3 react to give you how many moles of AgCl?
So 1 and 1.
Yep, it's 1 to 1, so I'm going to put the 1 mole of AgNO3 at the bottom to get my units to cancel out, and 1 mole of AgCl at the top. And we know that for every 1 mole of AgCl, there's about, using the periodic table, 143.32 grams of AgCl. All right, let's do this on our calculator. 0.9 times 143.32. Okay, we divide that by 169.87. 0.759 or 0.760. I'll round it up. So 0.760 grams of AgCl are produced if all the reactant, okay, which reactant is consumed? If all the silver nitrate reactant is consumed. right, so you tell me now, Alex, which is the limiting reagent? The reagent that will give you 2.21 grams of the product, or the reagent that will give you 0.76 grams of the product?
0.76.
Okay, you cannot make 2.21. Impossible. Why? Because after you make 0.76, all of this is gone. All of this is gone, and once all of this is gone, the reaction stops because you have no more reactant. It's like you ran out of eggs, so you cannot make cake. Okay? So yes, AgNO3 is what we're going to call the limiting reagent. Okay? So where were you getting this 105%?
To be fully honest with you, I don't
So
know.
we want to figure out the percent yield, right? So how much can you, in theory, make? In theory, if we were perfect robots and human beings, in theory, based on the math, based on the balanced chemical equation, based on stoichiometry, we can make 0.760 grams of this product. But how much do we actually make?
The 6.02.
The 0.602, correct.
Or yeah, 0.602.
Okay, to make everything as a percentage, we will multiply this by 100. So 0.602 divided by 0.760. It's a 79.2% yield. Is that what you're getting? Where was the 105% coming from? Is this something you can
Let's see.
understand?
Actually, yeah, I think I'm starting to see it right here. So when I was calculating the theoretical yield, here, do you want me to come show it to you?
Oh, that's fine. You can explain
Okay.
it to me.
So I took the 0.9 grams of silver nitrate
Yeah.
times 1 mole of silver nitrate over the mass of it
Right.
per mole.
Correct.
Times, like we did the 1 mole of silver nitrate and converting it to silver chloride.
Right.
And from there I got 0.004 moles of silver chloride. And so I did another set of fractions going through. So 0.004 moles of silver chloride, and I times that by grams per mole of silver chloride. And that is what gave me 0.573.
Even then, that should not give you 105% yield. Is this what you've got in your problem?
Well, let me see if I added it up right.
Grams, moles of AgCl. Cancel out moles of AgCl.
Yeah, here it might just be. You might be able to see something that I might have missed. That's right. Yeah, I guess I'll scoot this off to the side. But that top one right there is where I started at. So the 0.9 grams.
1 mole is that, times 1 mole, 1 mole.
And so I took that and plugged it in over here and kept it going.
Okay. Maybe I did the calculator wrong. So 0.90 grams. Divided by 169.87. I'm not getting that.
Well, then maybe I plugged it in wrong. Divided by 169.87.
Yeah. That's what I'm getting.
So I got from that is
That's moles.
I got what would be 0.005. So that number right there.
529 if you want to carry some extra digits. Yeah.
529. 00529.
Times 143.32, 0.759. Yeah.
Okay. So I must have just done the wrong calculation then.
Right, calculator error.
Okay.
Well, still that doesn't explain the 105% yield because you can never get more than 100%. There's no extra credit in a limiting reactant problem.
If only.
So when you do the reaction, you can only get 100% of the product, but usually we don't. And don't forget, percent yield is the actual yield divided by the theoretical yield. And again, to get it as a percentage, you multiply it by 100.
Okay. So let's see. Oh, so the original question I had before we realized that ugly mess that I had going on.
All right, so now we are done with this. It's not 105%. You can never exceed 100%.
Exactly, yeah.
All right, so what was the original question?
So this one was looking back at what we just fixed with that was our part 1% yield.
Okay, that's part 1% yield.
Let me make sure I've got my part 2% right.
What's the difference between part 1 and part 2?
So in the lab, part 1, you're sitting there and you're mixing 1 gram of sodium chloride and 1 gram of silver nitrate.
Okay.
And then in your pre-lab, we're automatically going to have 2 grams of sodium chloride, but we have to kind of calculate how much silver nitrate we're going to have so that they'll fully react with one another, fully use it up.
Okay.
And do you want me to show you that part first to make sure I've got that right?
Let's go over that. So,
Okay.
So what do you have to do in part 2? Let's write our equation here.
Yeah, so here's that question for you out of part 2.
By the way, in part 1, you start with 0.9 grams, right? Or not
Yeah.
one?
Oh no, that was a different thing. That
It's
was
something else.
Yeah, that was another question in the
This is a
pre-lab.
pre-lab. Okay.
Yeah. Yeah, the part 1 is very similar because it will do
so this
1
is
gram and 1 gram.
Okay, so you'll do the exact same thing for this procedure, 1 gram and 1 gram.
Yeah, just slightly different number.
Instead of 0.90 grams, you'll put 1 gram.
Yep.
And do the same thing. Okay, so what is it in part 2 are they asking?
So in part 2,
How much? You have
So-
2 grams.
of NaCl. And we're trying to find how much silver nitrate we need to have to add to that 2 grams to get it completely reacted.
How many grams of silver nitrate do you need to completely react with the NaCl? Okay. I think that's pretty straightforward to me. So you're going to start out with 2 grams of NaCl. Okay, we're going to convert it to moles.
Yep.
1 mole of NaCl has how many grams?
It has 58.45.
5 grams of NaCl. Okay, how many moles of NaCl react with how many moles of AgNO3 to get this?
That's 1 to 1.
1 to 1, very good. Okay, that's why we always balance. And 1 mole of AgNO3 has how many grams of AgNO3?
1 mole of AgNO3 has 169.
169, yeah,
0.87
0.87 grams of AgNO3. Okay, Okay, so this is stoichiometry, and this tells you how many grams of NaCl will react completely with AgNO3 if you start out with 2 grams of the NaCl. So 2 times 169.87 divided by 58.45. I'm getting 5.81 grams of AgNO3. Okay, reacts completely with the 2 grams of NaCl. Okay, according to stoichiometry.
How I had originally done it was converted the 2 grams of NaCl to moles.
Correct.
To find out how many moles of NaCl was 2 grams.
Correct.
And so what I figured, and correct me if I'm wrong, is that we need to have the same moles, not necessarily the same grams, because the moles will weigh out differently between the 2 different reactants.
Okay.
So we got how many moles was in that one, and so I took that answer and basically plugged it in and backworked it. How would I explain it? Like this right here. So I took that right there. So that many grams of silver nitrate is 1 mole of nitrate. How many grams of silver nitrate is in 0.0?
Where are you getting that 0.034?
That was what I had originally gotten when I just found out how many grams of NaCl switched to the moles.
Oh, you're saying they have to equal the same. Oh, I see what you're saying. So 2 grams is point whatever 3 moles, 0.03 moles, and you're wanting to see. I don't think that works because your units are going to be grams per mole, and I think I see your line of thinking, but
it's just a little bit off for what I'm trying to find.
Now you want to use the balanced chemical equation and the mole-mole ratio, which is 1 to 1.
Okay.
What happens if you solve that? What do you get?
Well, I did. So I took it. I had it stop right there. It was 2 grams NaCl.
And then you want to figure how many moles of NaCl is equal to that many moles of AgNO3.
Yep. And so then I did that, and I brought over the 0.034 and multiplied it, and I got 5.78 grams.
Okay, it's pretty close, yeah. So, yeah. You know why that works? Because they're in a 1 to 1 ratio. But if it was 2 to 1 or 3 to 1, then that answer would be incorrect.
Okay. So safer to learn your style just in case.
Yeah, your style is correct because for every one of this, 1 reacts. That's why you can use that type of rationale. Because there's 1 mole reacts with 1 mole. But when you balance it and it's not 1 to 1, then that will not be the right answer.
Okay. All right.
So you're right. The reason why you're right is because of this. For every 1 mole of AgNO3, there's 1 mole of NaCl.
Well, yeah, trust me, I'm definitely going to try and get your way down, Pat. I just was wondering how
But that's right, because it's 1 to 1.
Okay.
So that's why you always want to balance the equation. So yeah, 5.81, 5.78, that's like a rounding error. That's not a problem. That's the right answer.
Okay.
All right, so now the original question.
The original question was if the experiment only has 83.7% yield.
Okay, so Now we come back.
And we just talked about part 2. There was a part 1 in there that was the 1 mole of NaCl, 1 mole of
1 gram.
Nitrate. Or yeah.
1 gram.
Yeah, 1 gram, my
that's
bad.
part 1. Okay. So let's just say percent yield is, this is the formula for percent yield. It's actual yield, how much you actually get out, versus theoretical yield. Okay, so we got our part 2, so part 2 here. We need to figure out how much AgCl we got, right?
Yep.
All right. Well, how much AgCl we got theoretically? Okay, theoretically. So since this reacts completely with this, there's really no limiting reagent because this reacts completely with that. There's
so
no
they'll both
excess.
be used up at the same time.
Yeah.
Okay.
There'll be, once this reaction is complete, they'll have 0 of this and 0 of that. Okay, why is that? Okay, because it reacts completely. Okay? It reacts completely. That's why you don't have to go through what we went through with all of this stuff. Okay? Because it reacts completely, there's no limiting, there's no excess. 2 grams of NaCl will react with 5.81 grams of silver nitrate. Nothing is left over. Nothing will be left over, and nothing will be left in excess.
Yep.
Okay, we need to figure out how much we'll make of this. Okay? So I'm just going to pick the 2 grams of NaCl. Okay, you can get the same answer with the 5.81 grams, but for every 1 mole of NaCl, there's 58.45 grams of NaCl. Okay, it's a 1-to-1 deal. For every 1 mole of NaCl, there's 1 mole of AgCl. Now let's go ahead and convert this to grams. For every 1 mole of AgCl, there is 100, and I have it here, 143.32 grams of AgCl. Okay, because it reacts quickly there. Because it reacts completely, there is no excess or limiting. All right, so grams of NaCl cancel, moles of NaCl cancel with moles of NaCl, moles of AgCl cancel with moles of AgCl. So we have 2 times 143.32.
And then divided by 58.45.
4.90 grams. Or 4.90 grams of AgCl.
And that would go into our actual yield or theoretical?
That's your theoretical.
Okay.
The actual yield, well, our percent yield is how much percent? 83.1%?
83.7.
Okay, so if our percent yield is 83.7%, let's convert that to our decimal point, 837. Equals, our theoretical yield is 4.90 grams. Our actual yield is what we want to solve for.
So you just multiply the 2?
Yeah, 0.837 times 4.90 grams. Um, 4.10 grams is the actual yield.
Okay.
grams of this AgCl. Okay, that's part 1 precipitate. Part 2 of the precipitate. Yeah. So 4.10 grams that you produce of this will give you 83.7% yield.
Okay. All right.
So you're going to do the same thing with part 1. But part 1 you're going to use, first of all, for part 1 this will be 1 gram.
Yep.
And then 1 gram. And then you're going to use the limiting reagent.
Okay. Now when we're doing theoretical yield, which one is it that we start with? The limiting or the...
Everything starts with the limiting.
Okay.
The limiting reagent sets your limit.
So we would start here with our limiting, so we'd have 1 gram of silver nitrate.
Provided that's the limiting reagent. I would go through all of this again, but instead of 0.90 grams, it would be 1 gram.
Okay.
I mean, we can do that really quickly on our calculator. Okay, for 1.0 grams of NaCl for part 1. Okay, so instead of 0.90 grams, we'll do 1 gram. So 1 times 143.32 divided by 58.45. So you're going to produce 2.45 grams of AgCl. Okay, you see how I'm getting that? Instead of 0.90 grams, we do the exact same thing.
Yeah, because all the other values throughout it will be the same.
All the other values will be the same. Okay, same thing here. For 1 gram, now this reagent is AgNO3, will produce, okay, 1 gram
times 143.32, and then divided by 169.87.
Will produce 0.844 grams of AgCl. Okay. So what is the limiting reagent if you're starting with 1 gram?
It'd be the AgCl.
Right. You're going to produce once you produce 0.844 grams of AgCl, the reaction stops. Because now you're done. You're totally consumed. You have 0 of this reaction.
No gas left in the tank.
Yeah, no AgNO3 left in the tank. Specifically, yeah, exactly. Okay. So this also is our theoretical yield. Okay, this also is our theoretical yield.
So theoretical yield, you'll start out with both of them, just to check and make sure you do the calculations for both of the reactants.
Yes.
So you do that, and you convert that to the grams per mole of that reactant, and then you do how much of that reactant in moles converts into moles of the product.
Right, the mole-mole ratio, and in this specific example, it's 1:1.
And then, and do we always say that the product is the precipitate? I mean,
may or may not be. You can do this for I think in your homework problems, you do the exact same thing, and the product is a gas or something. Okay. So it doesn't have to always be a solid.
And then once you get that mole-to-mole ratio,
that's right.
Then
here.
you do the, then you do that mole. And would you say if it was a higher number than 1:1, say if it was 1:3, then would you do 3 down, or
no?
You would still do the same thing.
Yeah,
it would just multiply through.
Yeah.
Okay.
I mean, 1 mole is this. 3 moles is not that.
Okay.
So once you convert the mole to product, mole-to-mole ratio, then you convert that product to grams.
Okay.
And that's how you get the. In theory, we produce 0.844 grams. In theory. So for part 1, okay, starting out with a material of 1 gram, starting with 1 gram of this, 1 gram of that. This is the limiting. We're going to produce, in theory, nothing ever happens.
If everything was perfect.
If everything was perfect, 0.844 grams of AgCl. Well, everything was not perfect. We're not 100% perfect. We're 83.7% perfect. So 0.837
times or equals
your
the actual what's it called, yield over the
theoretical,
which was 0.844. You said,
which was 0.844. Yeah.
And like we did up there, we would just bring
Yeah.
that over and find the actual yield by multiplying the other two numbers.
Yeah. Okay, this is for the part 1. So 0.837 times 0.844. It's 0.706 grams. Of AgCl. So instead of producing 0.844 grams in theory, if you produce 0.706 grams of AgCl from starting material 1 gram of this and 1 gram of that, if you produce 0.706 grams, you are getting an 83.7% yield. Okay, that's your part 1. In part 2, starting out with 2 grams
Of NaCl.
of NaCl or 5.81 grams of AgNO3. If you start with those 2 starting materials, they react completely, so no excess, no limiting. If you produce 4.10 grams, if you get 4.10 grams, you're getting an 83.7% yield.
Okay. That makes a whole lot more sense than when I was trying to go through it last night.
Yeah. So that's a little tricky, but yeah. So let's see something. So, I chose NaCl because it reacts completely. I could also choose, because there's no limiting or no excess, the problem tells you it reacts completely, so I could also choose 5.81 grams.
And ask how many grams of NaCl would be needed to react completely.
Or how much AgCl I would produce. So 2 grams produces 4.90 AgCl. How much AgCl would you produce with 5.81 grams? So 5.81 grams of AgNO3 times for every 1 mole of AgNO3 is 169.87 grams of AgNO3. Okay, remember, based on the balanced equation, this is 1 to 1. 1 of this, 1 to that. And for every 1 mole of AgCl, there's 143.32 grams of AgCl. Okay, so in this part 2 answer, it reacts completely. We said 2 grams, which they gave us, reacts with 5.81 grams completely. Okay, this is what we calculated. No limiting, no excess. So let's start out with 5.81 grams of AgNO3 and see how much AgCl we get out based on our stoichiometry and balanced chemical equation. 5.81 times 143.32 divided by 169.87. Something's not right here. 5.81 times 143.32. Divide this by 169.87. 4.90 grams.
All right.
I told you there's no limiting, there's no excess here because it reacts completely. Okay. There's no limiting, no excess because they react completely.
Awesome. Well, thank you so much.
All right. So use this to look over. Hopefully this makes a little bit more sense now.
Oh yeah, absolutely it does.
And